All right, so our last page, we're converting between volume and moles. And volume is the quantity, but we measure volume in liters. So we're converting between liters and moles. And 1 mole of any gas equals 22.4 liters. Now, this conversion factor only works if you have a gas. It's only for gases. Whoops, I already had that written on the paper. Only for gases. So we can only use this for things that are a gas. But pretty much everything in this unit that asks you to convert 2 liters will be a gas because we want to be able to use this particular conversion factor. And molar volume of gas is one of your vocabulary terms. It's the volume occupied by 1 mole of a gas at standard temperature and pressure. And later in the semester, we may talk about gas laws, and then we'll learn about times where we're not at standard temperature and pressure. But for now, you can just ignore that part of the problem. If it says it's at STP or at standard temperature and pressure, that just means you can use this conversion factor, the molar volume of a gas. We're going to assume that everything we're doing right now is at standard temperature and pressure. Anybody have questions on that before we keep going? All right, number 9. How many liters does 2.10 moles of oxygen gas take up? So we're looking for our value, unit, and substance. And so we're starting out with our value 2.10. Our unit is moles, and our substance is oxygen. And when we're talking about oxygen gas, or any type of gas, that's going to be where we have to check our list of diatomics. And if we have a gas that's a diatomic, we have to put that little subscript of 2 next to it. So looking at our periodic table, remember the diatomics are hydrogen, and then the ones that make the 7 on the periodic table: nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So these are our diatomics. If we have a diatomic that's a gas, then we do need to put that subscript of 2. So oxygen is a diatomic. So when we write this problem out, 2.10 moles, we'll abbreviate mole, but instead of just putting O for oxygen, we're going to put O2 because we know that it's a diatomic. It will come in a pair. And we'll put it over 1. Then we'll multiply by our conversion factor. And the unit we want to cancel is this moles of O2. So we're going to drag and drop that on the bottom. Moles of O2. And then we're trying to convert to our new unit. It says how many liters. So that's our new unit, is liters. That's what'll go on top. And it's still the same substance, so it's still going to be O2. Any questions on how we got that set up or anything so far? All right, so anytime we have moles, we know what number we put next to moles. It's always a 1. 1 mole equals some number of liters, and that number is this 22.4. 1 mole of any gas equals 22.4 liters. So that 22.4 goes next to the liters. Now that we have this set up, all we have to do is put it in our calculator. 2.10. 2.1, we don't need the 0, times 22.4 gives me 47.04. And then I need to look back at my problem for significant figures. 2.10, that has 3 significant figures, so my answer also needs to round to 3. We'll look at that 4 to tell if it stays a 0 or rounds up. 4 is less than 5, so it's going to stay the 0, 47.0. My moles of O2 cancels out, and my final unit is liters of O2. Liters O2. I'll box in that final answer there. Questions on that first problem? All right, moving on to number 10. How many moles are contained in 54.6 liters of neon gas? So once again, we're starting with our value, unit, and substance. 54.6 is our value. Our unit is the liters, which is hard to underline, so small, of neon gas. Neon is our substance. And we need to check to see if it's diatomic. Neon is not part of our 7. It is not diatomic, so we can just put that symbol neon. So let's write that out. 54.6 liters of neon, Ne. Put it over 1 and then multiply by our conversion factor. The unit we want to cancel goes on bottom, so that would be the liters of neon. We'll drag and drop that on the bottom, liters of neon. And the unit we're trying to get to that's new goes on top. It says how many moles. So we're trying to get to our moles. So that's going to go on top. Moles of neon. Now that we have this set up, we need to fill in our numbers. Anytime we have mole, we put a 1 next to it. 1 mole of neon. And we know that 1 mole of a gas equals 22.4 liters, our number at the top. So next to liters, we'll put that 22.4. Now we need to use our calculator. Let's see, a little bit of glare there. 54.6 times 1 is still 54.6. Divided by 22.4 gives us 2.4375. Now let's look at our significant figures. So we have 1, 2, 3 significant figures here. We need 3 in our answer as well. And we'll look at that 7 to determine whether it rounds up or stays a 3. 2.4, and that 7's bigger than 5, so we'll round that 3 up to a 4. 2.44 liters of neon cancels, so we're left with moles of neon as our final unit. There's our final answer. Any questions on that one? All right, on to number 11. How many liters are occupied by 0.987 moles of chlorine gas? So let's start out with our value, unit, and substance. 0.987 is our value. Our unit is moles. Our substance is chlorine. And we need to check whether chlorine is a diatomic or not. Looking at our periodic table, chlorine is part of that 7, so it is a diatomic. So we write out chlorine. We won't just put Cl, we'll put Cl2. So 0.987 moles, MOL, chlorine, Cl2. Put it over 1 times the conversion factor. We're going to drag and drop this moles of Cl2 to the bottom. And the unit we're trying to convert to goes on top. It'll be next to the question word, how many liters? So on top are liters of Cl2. Anytime we have mole, we put a 1 next to mole. And then we put that 22.4 liters next to liters. 22.4 liters in 1 mole. Now we just need to use our calculator. 0.987 times 22.4 gives us 22.1088. And let's look at our significant figures. We have 1, 2, 3 significant figures in our given value. So our answer also needs 3, 1, 2, 3. And we'll look at that 0 to figure out whether it rounds up or stays a 1. 0 is not more than 5, so it's definitely going to stay a 1, so 22.1. And then moles of Cl2 cancels, and we're left with liters of Cl2 as our final unit. Box that answer in. Anybody have questions on that one? All right, on to the last one. How many moles are in 895 liters of helium? Value is 895, unit is liters, and helium is our substance. Let's check to see if helium is a diatomic. Helium's up here. It is not part of our 7, so it's not a diatomic. So we'll just do 895 liters of helium, He. Put it over 1 times the conversion factor. We're going to drag and drop our liters of helium, so that goes on bottom. And then our new unit that we're converting to will go on top. It says how many moles. So moles is what will go on top. Moles of He. Anytime we have mole, we put a 1. And then we know that 1 mole of any gas equals 22.4 liters. So let's put this in our calculator. 895 times 1 is still 895. And then divided by 22.4 gives us 39.9555. Now we need to round to correct significant figures. We have 1, 2, 3 significant figures in our answer, or in our given value, excuse me. So we need to round this value to 3 significant figures, so 39.9, and then we'll look at that 5 to determine whether to round up or stay the same. Now this 5 means that the 9 needs to round up to a 10, but if this 9 rounds up to a 10, then that means we need to round the next place over as well. So we're going to put this 9 rounds up to a 10 as well, so we'll round this up to a 4, 40.0. To show that all 3 of these digits are significant, we do need that decimal point and that 0. So we have 3 significant figures rounding this 39.95 correctly. Now let's put some units. Liters of He cancels out, and we'll be left with moles of helium. Box that final answer in. Anybody have questions on any of those?